What's up? I'm Vin, and today I want to go through the June 2023 Geometry Regents, and I'm going to do the multiple choice questions in this video. I'll leave a link to a copy of those questions in the description below. And now let's get started. First up here, we have a square pyramid is intersected by a plane passing through the vertex and perpendicular to the base. So this is the $1,000,000 phrase right here. And we want to know which two-dimensional shape describes this cross-section. So anytime they tell me to describe a cross-section, I always think of deli meat being sliced. And the idea is we have this 3D solid here. And if we were to take a slice of this, and the way that we're slicing this is we're slicing it perpendicular to the base. So that means we're going straight down towards the base like this, and we're passing through the vertex. The cross section that we would be looking at here if we were to slice this thing would be a triangle, because once again, if I just took a knife or a sword or something and I sliced this thing straight down towards the base, going through the vertex like this, notice that if I were to open this thing up, we would be staring at a triangle here. So that's our cross section. So one extra detail before we move on, if we were to slice this thing parallel to the base, that means we would be slicing it this way. We would make a horizontal chop like this. And then the cross section we would be looking at here would be a square. But since we are slicing it vertically, we're looking at a triangle. Choice 2 is our answer. Question 2, we have trapezoid ABCD is drawn such that segment AB is parallel to segment DC. And we have trapezoid A prime, B prime, C prime, D prime is the image of trapezoid ABCD after a rotation of 110 degrees counterclockwise about point P. And we want to know which statement is always true. So for this question, the concept that we need is that a rotation is a rigid motion. It preserves distance and angle measure. So now using this concept, we could go through all of the answer choices here. So let's see. First up, we have angle A is congruent to angle D prime. Now this one here is not always true. What we can say for sure is that angle A is always congruent to angle A prime because they're in corresponding locations. When we rotate this trapezoid, angle A is going to fall exactly on top of angle A prime like this. However, we can't guarantee that angle A is congruent to angle D prime. The only way that would work would be if this was a trapezoid where we had two right angles here like this. So if it was this kind of trapezoid, then we could say that choice 1 is always true. But once again, we don't have right angles there, so we can't say choice 1 is always true. So this one is not our answer. So now 2, we have AC, so that's this diagonal, is AC congruent to segment B prime, D prime. So if we look over here, this one is not always true. The only way that would be true would be if AC was congruent to BD. And that would only be true if we had an isosceles trapezoid. If we were told that AD is congruent to BC, then 2 would always be true, but they didn't tell us this is isosceles, so we can't say that 2 is true. So let's just cross this off again. This is not our solution. And we'll just get this out of the way so we could consider the next answer choice. So 3 is A prime, B prime. And once again, let me just erase this here. We'll get this out of the way. So is A prime, B prime parallel to D prime, C prime? This one is in fact our answer here because we were told AB is parallel to DC. So when we rotate parallel lines, the lines are going to stay parallel because the distance between them does not change. And if they're already parallel and you maintain the distance between them, they're going to stay parallel. So 3 is definitely our answer. Now, why is 4 no good? Well, here they're saying that B prime, A prime is congruent to C prime, D prime. Well, this wouldn't be true because if we had one pair of sides of our quadrilateral both parallel and congruent, that would make this a parallelogram. Okay, so that would switch this to a parallelogram. But just know what makes a trapezoid unique is that it has exactly one pair of parallel sides. This would once again turn it into a parallelogram, and then both pairs of sides would be parallel, and it would no longer be a trapezoid. So that's why choice 4 is no good. So we could cross off choice 4, definitely choice 3. Question 3, what is the volume of a right circular cone that has a height of 7.2 centimeters and a radius of 2.5 centimeters? And we're rounding to the nearest tenth of a cubic centimeter. So for this one here, we have to know the volume of a right circular cone, which is 1/3 pi r squared times h. And now we just plug into the formula. So we're going to have volume equals 1/3 pi. The radius they gave us is 2.5. And here we don't have to include the units because notice all the answer choices don't have units attached. They tell us to the nearest tenth of a cubic centimeter. So they take care of the units within the question itself. So we have 2.5 as the radius and it's being squared. And then we multiply by the height, which is 7.2 centimeters. And the rest is calculator work. So now we just type this in. We're going to have 1/3, and we could write 1/3 in parentheses, but it's not important. If we didn't write it in parentheses, we still get the same answer. And we press second and the up arrow here to pull up the pi button. And then we have 2.5 squared. So we're going to write 2.5, close the parentheses, and square it. And then we could put parentheses 7.2. So we work all of this out here and press enter, and we're going to get 47.1. Now we'll just go over real quick. How do we round to the nearest tenth? So the tenths place is 1 after the decimal, and we look to the right and it's a 2. So that tells us to round down to 47.1. So that's why this is choice 2. The only reason why I go over this is because in the free response, you are going to have to round at some points, and that's an annoying point to miss out on. So just make sure you're okay with rounding. Question 4, we have a diagram of right triangle sun. Angle N is the right angle, and we're told SU is 13.6, SN is 12.3, and we want to know what is the measure of angle S to the nearest degree. So for this one here, it really helps to know this mnemonic, SOHCAHTOA, because SOHCAHTOA is going to help you choose the correct trig function to find the missing angle. So if our goal here is to find the measure of angle S, that's over here, this is one of the acute angles, we have to think, what side did they give us? They gave us 12.3, which is adjacent to S, because it's right next to it. Technically, this is next to S as well, but it's across from the right angle, so this is automatically the hypotenuse. And then across from S would be the opposite side. So when I look at what they gave us 12.3, which is adjacent to S, and they gave us 13.6, which is the hypotenuse. So when you hear the phrase adjacent hypotenuse, that should make you think of cosine, because cosine, the CAH in SOHCAHTOA, means cosine of one of these acute angles in a right triangle is the ratio of the side adjacent to the hypotenuse. So then that allows us to say cosine of the angle S is equal to the side adjacent is 12.3 units long over the hypotenuse is 13.6. So now to solve for the measure of angle S, we just have to think about what is the opposite of cosine, and that would be the cosine inverse function. So we take cosine inverse of this ratio of 12.3 over 13.6, and then we just type this in. Now, one thing to be careful of, don't just go cosine inverse of 12.3 divided by 13.6. So if you just do this and you just rush and you say, okay, my answer is 0.44, this is a very, very dangerous bear trap for the calculator, okay? You have to make sure, notice that it says radians up top. You want to make sure for this part you're in degree mode because it says to the nearest degree. So we scroll down after we press mode and we go over to degrees and we press enter. And then we clear this out, and now we could just go back to the previous line and we could try again. And this time around, we get a nice angle. So the measure of angle S to the nearest whole number, so we look at the whole number here, we stop here at 5, and we look to the right, it's a 2. So we're going to round down to 25 degrees, and this is going to match choice 1. Question 5, we have a diagram of circle O. AOB is a diameter, and chord CB is drawn to form angle B. And notice that angle B is an inscribed angle because the vertex is on the circle, and the measure of the angle is 28 degrees. But we want to find what is the measure of arc BC. So we want to find the measure of this. So this one is a nice question here, and it's a two-step question. So what we want to find first is the measure of this arc AC. And just know here that whatever the measure of this arc is here, the inscribed angle is half the measure of the arc. So what that tells me is I'm just going to do 28 degrees times 2. And that's going to give me 56 degrees. And that's going to tell us the measure of arc AC. But now they told us that AOB was a diameter. So that means that this measure here, let's say I call it X, that this measure X plus 56 takes up half of the circle. So this is going to equal 180 degrees. Okay, because once again, the diameter cuts the circle in half, and in a full circle, we have a 360 spin, so half of the circle would make up 180. So now I just subtract 56 on both sides. And for this part here, we just work this out. X is going to equal, and if we do 180 minus 56, that's going to be 124 degrees. So this is going to match up with choice 2. Question 6, we have a diagram of parallelogram ABCD, and the diagonal BED and segment EF are drawn. We're told that EF is perpendicular to DFC. So the first thing I'll do here is label this as a right angle in both of these spots here. And then we have the measure of DAB is 111 degrees, which is labeled for us. And we have the measure of angle DBC is 39 degrees, which is also labeled. But the goal here is to find what is the measure of angle DEF. So that's this angle over here inside this right triangle. Now for this one, there's a few ways that we could go forward with this. And this is a nice question because it mixes a lot of concepts together. But one thing I noticed right away is that angle A is opposite of angle C. And just know that in a parallelogram, opposite angles are congruent, so they're equal in measures. So that means this angle over here is also 111 degrees. And now notice, we could just answer this right away that we have a quadrilateral here. And just know, if you didn't know this, that a quadrilateral, no matter what it looks like, so a four-sided figure, no matter how I draw it, is made up of two triangles. So let me just draw that a little bit neater. So what I know right away is that the sum of the interior angles of a quadrilateral is 360 degrees. And the reason being, if it's made up of two triangles, the sum of the interior angles of one triangle is 180. And it's the same thing for the second triangle. That's true for any two-dimensional triangle. So if I did 180 plus 180, the sum of the interior angles of any quadrilateral is 360 degrees. So now when I want to find what is the measure of angle DEF, what I could do is I could target this angle over here. So now let's say I just put an x here for now. What is the measure of x? Well, I know that x plus 90 plus 111 plus 39 has to make 360. So if I add those up right now, so I'm going to add up, we're going to have 111 plus 90 plus 39, and then whatever x is going to have to make 360. So I could add these three angles together, and let's see what we get here. So we get 0, carry the 1, we get 4, and we're going to carry the 1 like this, and we get 240. So right now we have 240 degrees, so that means that x plus 240, so x plus 240 would have to make 360 degrees. And that tells you that x, if we subtract 240, is 120 degrees. So this x here, now I'll erase this, is 120 degrees. So let me just get that out of the way. So we have x is 120 degrees. So if we want to find what is the measure of this angle here, DEF, notice that it forms a straight line with the 120. So now I could just say, all right, 180 minus 120 is 60. So this missing angle here is going to be 60 degrees, and we're going to get choice 3. Now, another option here, you could say this is 111, so this is 111. And then you could focus on this triangle here like this. So this triangle that I'm highlighting in purple like this. So we could focus on this big triangle here. So if this is 111 and this is 39, we could find this missing angle by doing 111 plus 39 like this. And let's see what this gives us here. So we're going to have 5, 1. So that would tell us that this missing angle down here is 30 degrees. And then if this angle here is 90 and this one is 30, that makes 120. So if we do 180 minus 120, we also get 60 degrees here. So this way is probably a little bit nicer here. But once again, these questions, what's nice about them is you could take many different paths and it'll still get you to the same answer, which in this case is choice 3, 60 degrees. Question 7, we have a diagram of triangle ACT, and then the line ES is drawn parallel to segment AT. So I'm going to label this line here parallel to this segment. And then we're told E is on segment CA, S is on segment CT. Which statement is always true? Now, right away, what I'm thinking about with a question like this is that the two triangles involved are similar. And it can be very helpful here if you draw the triangles separate. So we have triangle CES, that's the small triangle. And then we have the big triangle, the original one here, which is triangle CAT. So now, looking at this, I'm ready to go through the answer choices. We're asking here, is CE, so CE is the left side here. So is the left side over the left side of the big triangle? So we have the ratio of the small left over the big left. Is that equal to the ratio of the small right side? And right away, I'm thinking, okay, that denominator better say CT. Because if we're comparing the entire right side of the small triangle, we need the entire right side of the big triangle. But notice they say ST, which is just one piece instead of the entire CT like this. So that's how I know this answer choice is out. What would make it correct would be if this said CT like this. Then it would be correct, but that's not there, so 1 is out. So now we look at the next answer choice here. We have CE over ES. So CE over ES is the left side over the bottom side. So it's the left over the bottom. And is this equal to, we have EA. So EA, right away I could see that this is not the left side of the big triangle. It's falling a bit short here because remember, E is over here on this big triangle here. So EA is already no good. If we wanted this to be correct, CE over ES, so the left side over the bottom side, would be equal to CA over AT. So the denominator was correct, but the top we would have to change to CA. We'd have to put the entire left side of the big triangle here. So 2 is out, and now we move on to 3. Is CE over EA equal to CS over ST? This one is in fact always true. This, there's a fancy name for it, is the side splitter theorem. Okay, so this is the side splitter theorem. So it really does help for you to show up to the test knowing your formulas and your theorems. Because if you look at this, you'll just say, oh, cool, that's the side splitter theorem. That when you draw a line parallel to one of the sides of the triangle and it goes through the other two sides, that it's going to cut the triangle proportionally. So now let's see why is choice 4 no good. So CE over ST. So notice what they're comparing here. They're comparing CE over ST. So this is like part of this over part of this. Is that equal to EA? So now they're doing like the bottom part here over CS. So they're just like zigzagging over the place here with choice 4. So that's how I know choice 4 is no good. Definitely choice 3. For question 8, we have two congruent triangles, triangles ABC and DEF, and we want to know which sequence of transformations maps triangle ABC onto triangle DEF. So for this question, I want to go with a visual approach. I notice that every answer choice is starting off with a rotation. So my first instinct is to rotate triangle ABC into quadrant 3, which we could do by rotating 90 degrees counterclockwise. So that would be if we spin this way, going towards the left. The Y that's facing up is, when we're done, going to be facing to the left like this. And then what I do with this information here is I say, okay, A prime, B prime, C prime. That's what I'm going to name this image here after the rotation 90 degrees counterclockwise. Let's see, where did A go? And then I treat this as if it was in normal position here. So to get to this new location here, I'll call this A prime, B prime, and C prime. So I would get to A prime by going 1, 2, 3, 4, 5, 6 to the left and down 2. So A prime is at -6, -2 like this. And then B prime would be -2, -2. So this is just a really nice trick here for rotating, because I can't remember the rules. There's way too many rules in geometry and I just can't remember them all. So to get to C prime, we're going to the left 2 and we're going down 1, 2, 3, 4, 5. So that would be -2, -5. So now think about, like, if we put the temporary location of B prime here for a moment, how do I then map B prime, which corresponds to the right angle here? Notice this is the right angle. So this represents the right angle. How do I get this point over to E? Because once again, if we want to have a map here, it's going to land exactly on top of triangle DEF with no spaces or overlap. So I need to get this point here to this point. I have to go to the right 1, 2, 3, 4, 5, 6, 7, 8. So then we would translate 8 units to the right. So now look at the answer choices. We're going to start off with a rotation of 90 degrees counterclockwise about the origin. And then we're going to be translating 8 units to the right. And that's going to give us choice 1. Now let's do a quick run through. Why are these answers wrong? Well, if we rotate 90 degrees counterclockwise, that's a correct start. But if we reflect over the y-axis, that would send B prime onto point D here. But notice this is the right angle, and D, this location of this angle, is not a right angle. So this doesn't map correctly. And if after we rotate 90 degrees counterclockwise, if we translated 4 units down, that would miss this triangle completely. That would keep us in quadrant 3. So this one is out. And now this answer choice is no good, because if we were to rotate 90 degrees clockwise, instead of being at this, well, we start at -2, 2 for the right angle, we would be at 2, 2. And then if we reflect this over the x-axis, this would map the right angle onto angle D here, which is not a right angle. So that's how I know choice 4 is out. Definitely choice 1. Question 9, we have circle M, and here's the equation for it. We want to know what are the coordinates of the center and the length of the radius of circle M. So for this one here, we have to know how to complete the square, and we have to know the equation of a circle. So when we want to complete the square, we want to get the x terms together, and we also want to get the y terms together. And then that constant, the +1, I'm going to just move that to the other side by subtracting 1. So to start this off, we're going to have x squared, and we're going to have plus 6x. I'm going to leave a space here, so I'll leave a little space. And then we're going to have the y stuff. So we're going to have plus y squared minus 2y. We leave another space so we could complete the square for this part. And now this is equal to -1 because we subtracted 1 on both sides. So this part just cancels out. So now to complete the square, you want to think of a quadratic expression, ax squared plus bx plus c. And the technique you're going to use is you're going to identify the b term. You're going to take half of the b term and square it. So looking at this equation here, the b term for the first part is 6. That's the coefficient of the x. So I would take 6, I would divide it by 2 and square it. And that would give us 3 squared, which is 9. And that's the mystery number I want to add to both sides to start this off. And now for the y stuff here, the b term is -2. So I would take -2, I would divide it by 2 and square it. And that would give us -1 squared, which is 1. So for this part, I'm going to add 1. And then I have to do the same thing to the right side to keep everything balanced. So now, why is this called completing the square? Is because now the resulting trinomials are perfect square trinomials. If I look for two numbers that have a sum of 6 and a product of 9, the two numbers would be 3 and 3. So this would factor nicely to x plus 3 times x plus 3. And if I think about this, x plus 3 times x plus 3 is just x plus 3 squared. So I'll just write that all at once. So we'll just do that all at once here. We're going to have x plus 3 squared. And now if I look at this next part, so that was this part here, this next part, y squared minus 2y plus 1, if I look for two numbers that have a sum of -2, and the two numbers also have to have a product of 1, the two mystery numbers would be -1 and -1. So I would have y minus 1. So I would have y minus 1 times y minus 1 if I factor this. But once again, that's going to factor nicely to just y minus 1 squared. So I'll just write that all in one shot. We'll write plus y minus 1 squared equals, and here -1 plus 1 cancels. We're left with just 9 on the right side. So then the next thing we have to know here is the equation of a circle. So anytime you have a center of hk, so your center is hk and your radius is r, so we'll say here radius r, the equation of a circle is going to be, we have x minus h squared plus y minus k squared is equal to r squared. So when I'm identifying the h and the k, one thing we have to be very, very, very careful with is notice there's a minus in front of the h. So when I'm identifying the center, I just have to make sure that I flip the sign in front of the x and the y. So notice it's x plus 3, so my center would be at -3, and in front of the y we have a -1, so I flip that to +1. Because if you see here, if I plug in, this is our h and this is our k, if I did x minus -3, that would change to x plus 3. So just be careful at that step because that's an annoying thing to miss out on. And then our radius here, we also have to be careful here. If we get this far and then we say, okay, cool, I got my answer, it's choice 3. We have to be very careful, okay? This is a very dangerous bear trap. What you have to make sure that you do is notice the radius is being squared. So our radius here would be the square root of 9, which would be equal to 3. So our radius would be 3. Our correct answer is going to be choice 4. Question 10 is all about you showing up to the Regents knowing your definitions and theorems. So we have parallelogram Beth, and it has diagonals BT and HE drawn in. Which additional statement is sufficient to prove that Beth is a rectangle? So for this one, we have to know this information. We would have to know that a parallelogram with congruent diagonals is a rectangle, and we also have to know that a parallelogram with a right angle is a rectangle. So looking at this, if we were told that angle B, E, T, or H is a right angle, that would be enough to show that this is a rectangle. Or we could be told that BT, that diagonal BT, is congruent to the other diagonal HE. And just scanning the answer choices, I can see right away choice 3 matches up. So just once again, knowing your theorems and definitions makes this question very doable. But why are the other answer choices no good? Well, if we were able to show that BT is perpendicular to HE, that would prove that this is a rhombus, okay? So that would be enough to show that this parallelogram is a rhombus, because a rhombus, the diagonals are perpendicular to each other. So it's a parallelogram with perpendicular diagonals. And then what if we were told that BE is parallel to HT? Well, this is nothing new. This is just a result of Beth being a parallelogram. So once we know that Beth is a parallelogram, then it just follows that the opposite sides are parallel. So this is nothing new, so that's why we could cross out 2. And now, why is 4 no good? Well, if we're told that consecutive sides are congruent, if we're told one pair of consecutive sides are congruent, that's enough to establish that this is a rhombus. Question 11, we have a gardener wants to buy enough mulch to cover a rectangular garden, and the garden is 3 feet by 10 feet. One bag contains 2 cubic feet of mulch and costs $3.66. How much will the minimum number of bags cost to cover the garden with mulch 3 inches deep? So for this question here, the few things that are jumping out at me right away is that we have 2 cubic feet for every 1 bag of mulch, and the cost is $3.66. And we have a garden in the shape of a rectangle, but they're digging this down here. So this is going to turn it into a rectangular prism. So this is what we're imagining here. So we have this rectangular prism. This models the garden. And the dimensions here, this is 3 feet by 10 feet. And they're digging this down 3 inches deep. But notice the units don't match. This is the first thing that jumps out at me that's a little bit annoying here. We have feet, feet, and then inches. So ultimately, we need to be thinking in terms of cubic feet. So I would turn 3 inches into the units for feet. So this would turn into 1/4 of a foot. And we could get this by dividing by 12. If we want to see the real technical way, we're really multiplying by this conversion factor, 1 foot over 12 inches. And then inches over inches cancels. 3 over 12 reduces to 1/4. So this gives us the dimensions of the garden. And then we have to know the volume of a rectangular prism is length times width times height. So now just plug into that formula. The length is 3 feet. The width, we'll say, is 10 feet. And then the height is 1/4 of a foot. So you just multiply this out. 3 times 10 is 30, times 1/4 is 7.5. So we have 7.5 cubic feet like this. So now think about this very carefully. This is how much we need. So we need 7.5 cubic feet of mulch, and each bag contains 2 cubic feet. So at this part, we could just think about it. And the idea is we're not allowed to buy part of a bag. You can't say, hey, I need 7.5 bags of mulch. I need 7.5 cubic feet of mulch. You can't pour part of a bag out. Each bag has 2 cubic feet. So one bag would give you 2. 2 bags would give you 4 cubic feet, then 6, and then 8. So you can't say, oh, I have 6, I only need another 1.5, give me 3/4 of a bag. That's just crazy. They would just be very upset at you. So you have to buy that 4th bag. We need 4 bags of mulch to get at least 7.5 cubic feet. So now we just have to say, okay, the cost is $3.66 for 1 bag. So we're going to do $3.66 times 4 because we have to buy 4 bags. And if you just multiply these numbers together, you're going to get $14.64, which is going to match up with choice 3. Question 12, we have a diagram of triangle dog, which is similar to triangle cat, and we're told angle G and angle T are right angles. Which expression is always equivalent to sine of angle D? Well, one thing that's very helpful here is that if we're focusing on angle D, notice that angle D is over here, and in the letterings, D shows up first in the word dog. So if I look at the first letter of cat, it's C, and that tells me that angle C is congruent to angle D. Because remember, when you have similar triangles, the angles are congruent in both triangles. They're just a different size, but they're the same shape. So here, what I could do is I could just pick out values for this triangles. Let's say I'm going to make this one 3, 4, 5. And I'm doing this, I'm making it a Pythagorean triple so that the numbers are nice whole numbers. And then since these triangles are similar, this one's a little bit bigger than this one, I'm going to use a scale factor of 2. And now this is the short side, so now it's going to become 6 because I'm multiplying by 2. This one will become 8, and then this side will become 10. So now we're talking about trig functions. So this mnemonic is helpful once again. We have SOHCAHTOA. And remember, sine is the ratio of the side opposite to the hypotenuse, and that's when we're focusing on one of the positive acute angles in the right triangle. Cosine is the ratio of the side adjacent over the hypotenuse, and tangent is the ratio of the side opposite of the given angle over the side adjacent to the given angle. So now using that idea, sine of angle D, I'm going to just set that up over here. Opposite of angle D would give us 3. And then the hypotenuse of this first right triangle is 5. So now I'm just going to run through the answer choices and see which one gives us the ratio of 3/5. So if I did cosine of angle A, remember cosine is adjacent over hypotenuse. So if I'm focusing on A here, adjacent to A would be this side. So this would be the adjacent side to angle A. And that would give us 6 over the hypotenuse is across from the right angle is 10. And if we reduce this, divide the top and bottom by 2, this is going to reduce to 3/5. So right away, I could see choice 1 is our answer. Now, why is choice 2 no good? If we did opposite of A would be 8 over the hypotenuse is still 10. And if you reduce this, it reduces to 4/5, which is not 3/5. So that's out. And then tangent of angle A, if you go opposite of A, so tangent is opposite over adjacent, opposite of A is 8, over the side adjacent is 6, and this reduces to 4/3, which does not match 3/5. So that one's out. And then finally, cosine of angle C, if we go adjacent to C, that's 8. So that's the side next to angle C. Over the hypotenuse is 10. And this simplifies to 4/5. Once again, that is not 3/5. So choice 1 is definitely our answer. Question 13, we have triangle DEF is the image of triangle ABC after a dilation of scale factor 1/3. So we want to find the center of dilation in this question. Now, one thing that I imagine with questions like this is that when we have a triangle and a center of dilation, so here's our center, and I'll just draw some triangle out here like this. So here's our triangle. What I imagine is that when we have the center is I connect a dotted line in my head from the center to each of the 3 points of the triangle. Okay, and that's the pre-image. This is the one that we're actually dilating here. So I connect this, and then if I have a scale factor of 1/3, so I have k is equal to 1/3, then I think about all of these distances, and I'm going to draw a point that's about 1/3 of the way. So you see this would cut this first segment into a distance 1/3 of the way. And then this longer segment here, I would say it's about here like this. And then this last one here, I would say about here. And notice when I connect these 3 points that I have a new triangle that the side lengths are about 1/3 the length of the original triangle like this. So that's what you should be imagining in your head. If you had a scale factor like let's say 2, then you would extend the dotted line out like this, and you would double the distance, and you would draw your dotted line going out a little bit more like this. So I would double the distance like this, and that would give me a triangle that looks something like this, okay? So the scale factor also works when k is greater than 1, but this is what's going on in my head when I'm thinking about a question like this. So now we move on and we go through the answer choices. 0, 0 is no good, because if you imagine here, if this was your center and you're dilating this triangle, it's not going to land exactly on top of the center of dilation. It's going to, like the distance here you could see is going to go 1/3 of the way like this. So if I drew this, You see how if I went 1/3 of the way, that would give me something like, this is looking kind of weird. See how it does not land on top of DEF. So that's how I know that choice 1 is no good. Now, for these kind of questions, yes, you do need to have some sort of like imagination going on here, like imagining this stuff going on in your head. It really helps if you could visualize here. But 1 is definitely out. Now, 2, -3, so I'm going over 2, down 1, 2, 3. So this is looking good for our center, because if I draw in my dotted line like this, so if I draw in my dotted line, B would map to E. We have C mapping to F. When I draw a dotted line, and let me draw this a little bit neater, going from my point to its image and then to the center like this, you could see that F is about 1/3 of the way from this. Let me use a different letter. Of course, they use C here. So how about I use a different letter? Let me use something like W. So now W stands for center. That's just a bit annoying that they did that. So you could see that from W to C, W to F is 1/3 of that original distance. And now for this one here, this is going to be the most challenging one because it's so far away. Okay, but the same thing here. From here to here is 1/3 of the distance. If I wanted to be really sure, I could count for one of them. So let's say I erase this part here. So I get rid of this. And I'm going to focus on just going from here to here, from B to E. I'm going to count the distance from B to W. I'm going to go over 1, 2, 3. So I'm going to the right 3 units. And then I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to go over 3, down 9 to get from B to W. Okay, so this is to go from B to W. I have to go over 3, down 9. But now, how about to get from E to W, to get from the image to the center? So to get from E to W, I have to go over 1, and I have to go down 3 units like this. So notice what happened. The amount I have to go over and down was cut by 1/3. So if I multiply each of these by 1/3, I get 1 and 3. So that's how I know that this one here is looking good. And just for the sake of time, I'm not going to run A and D through the same test. But what you would essentially be doing here is you would count how much you have to go over and down to get from A to the center and see if the amount you have to go over and down to get from D to the center is 1/3 of what you had to do for A. And the same thing for C and for F. Now, let's see why the other answer choices are no good. So why is 0, -2 no good? And it's the same idea. If I scale this triangle by a factor of 1/3 from this center, that's not going to make this new triangle land exactly on the center because the original triangle is away. So if I draw my dotted line like this, you see how point F should be 1/3 of the way. It should be somewhere over here, not exactly on the center. So that's why, once again, 0, -2 is no good. So I get rid of 0, -2. And then -4, 0 is no good because if I dilate this triangle and my center is on the triangle, point F would still be on top of point C. So this one is out, definitely choice 2. Question 14, we have isosceles triangle AHE, and the vertex is at angle H. So if this is the vertex, then these are the base angles, and the base angles of an isosceles triangle are congruent. And then we're told that segment CB is perpendicular to segment AE. So that means that these angles here are right angles. And we have FD, this segment is perpendicular to segment AE. So we have right angles here as well. And which statement is always true? So for this one here, what I'm noticing is that we have these two right triangles that have two pairs of congruent angles. You see here that these right angles are the same, and then these notched angles at A and E are the same. So that means that triangle, we'll have triangle ABC is similar to triangle, and I have to make sure I set this up correctly. Notice A is the angle in the corner here, so I have to write E first, and then the right angle I wrote next, so I have to write the right angle next is D, and then F is the angle up top like this. So these two triangles are similar. And since we have similar triangles, that means the ratio of the corresponding sides are going to be in proportion. So I'm going to keep that in mind as I scan the answer choices. And another thing I could do to help me out here is that when I draw both triangles, right now the way that it's drawn, this is the small one and this is the big one. But since it's something that's saying which one is always true, these lines are not necessarily fixed in place. They can move all around like this. So I'm going to put them so that they're facing the same way. So I'm going to write B, A, and then C up here like this. And then I'll say the one that's bigger for now is triangle DEF. Okay, so I'm just putting them so they're facing the same direction because when we have to set up ratios in a moment, it's helpful when they're facing the same way. So let's see, AH over AC is equal to EH over EF. So let's think about that one here. AH is this entire segment here like this. Over, we have AC. And that's going to be equal to EH. So it's hard to draw those things backwards. EH over EF. So if we think about this one, the only way this would be true, because we know that AH and EH are equal in measure. So I'm just drawing these lines so we can see where to focus. But AH and EH, these two are equal. So these ones here are equal. So that would mean that AC and EF would have to be equal for this to always be true. But notice that AC and EF are not necessarily always equal, because this line DF could slide this way or it could slide back really close this way. So one is out. This one is not always true. It could be true if we drew this line in such a way that like these altitudes are the same. But the way it's drawn right now, no. So that one is out. Now 2 is saying AC over EF. So now we could use this diagram over here. AC over EF is we're comparing the hypotenuse of this one over the hypotenuse of this one equals, and now we have AB as the base. So right away, I'm saying, all right, the AB is the base of the small triangle. They should be comparing this to ED. And notice that they are, in fact, comparing this to ED. Okay, so let's just break this down one more time. We have AC, so that's the hypotenuse, over we have this hypotenuse is EF, is equal to AB is the bottom of the small triangle, has to be equal to the bottom of the bigger triangle. So this is definitely the one. But now let's see, why are the answer choices, the rest of them, no good? So we have AB over ED. So AB over ED is the bottom of the small over the bottom of the big. So we already have it written out over here. So it's the bottom of the small over the bottom of the big equals CB is the vertical side, and they should have FD written here. So this would be correct if they had FD written here, but they don't. They have FE. They're talking about the hypotenuse. So that's why this doesn't match up, okay? Because this is like, like leg, and then it's leg, and then they just throw in the hypotenuse kind of out of place here. So that's why this one is out. And now AD is this distance here over AB is equal to BE over DE. But once again, these are not necessarily equally spaced. If I drew this like way over here like this, so this is not drawn to scale necessarily. If I drew this way over here, then this just goes out the window. Okay, so choice 2 is our answer. Question 15, we have rectangle ABCD, and I'm not going to necessarily plot this. I'm just going to draw this out so I know where the corners are and where the diagonals are. So we have vertices A and B, and we want to find the slope of BC. So one thing to be mindful of, this is not drawn to scale, but A is at -1, -3, and B is at 6, 5. So if we want to know what is the slope of BC, notice we could find the slope of whatever AB is over here. So we could find this slope of AB, and BC is perpendicular to AB. Okay, so this is very important. AB is perpendicular to BC. So whatever the slope of AB is, we're going to find the negative reciprocal of that, because that is the relationship between slopes of perpendicular lines. So here we find the slope, we call this x1, y1, and we could call this point x2, y2. And just in case you forget, the slope formula, we have y2 minus y1 over x2 minus x1. So we find the difference of the y values, we have 5 minus -3, divided by the difference of the x values, we have 6 minus -1. And now on top, 5 minus -3 becomes 5 plus 3, which is 8, over 6 plus 1 is 7. So this is the slope of AB, but we have to be careful here. We can't say slopes of perpendicular lines are the same. That would be if we had a parallel side. If they wanted what is the slope of CD, then we could say 8 over 7. So now to find the slope of BC, we have to take the negative reciprocal of 8 over 7. So we need to flip it to 7 over 8, and we have to change the sign from positive to negative. Just in case you're not too comfortable with questions like this, just know if I had to find the negative reciprocal of something like -1/3, I would flip this to 3 over 1, and since it's negative, I make it positive. If I had a whole number, like let's say I had something, I'll write this over here, so more thoughts here. If I had something like, let's say 2, I'm going to call it 2 over 1, and I would flip it to 1 over 2, and then change the sign to negative. So you need that little skill here of how to find negative reciprocals. But in any case here, what we have, the slope of BC is -7/8, and that corresponds to choice 1. So we have another trig question here, except this time they didn't draw it out for us. We have to draw it out. We have right triangle ABC, and this doesn't necessarily need to be drawn to scale. So we have angle A is the right angle. That's the 90-degree angle. And then we have B as 18 degrees. And 18 degrees is kind of small, so I'm going to call this one angle B over here. So I'm going to call this one the 18-degree angle. And then C would have to be up here. And we're told AC is 8 units long, and we want to find to the nearest tenth the length of segment BC, and that's the hypotenuse, okay? So I'm just going to call this X for now, and that is the hypotenuse because it's across from the right angle. So we'll just label that here. This is the hypotenuse. And since we're starting with an 18-degree angle, Across from the 18-degree angle is the side that's 8 units long. So they gave us the opposite side. So now, once again, SOHCAHTOA, you want to think about which trig ratio uses the opposite side, and we want to find the hypotenuse. So which trig ratio uses opposite and hypotenuse? And that would be sine. Sine is the ratio of this side opposite of the given angle, the given acute angle in the right triangle, over the hypotenuse. So I would say sine of the angle is 18 degrees is equal to the ratio of the side opposite is 8 over the hypotenuse, we'll just call x for now. So now we solve for this. And for this part here, we just have to know a little bit of algebra. We're going to do x times sine of 18 degrees. And this is equal to 8 times 1, which is 8. And now just divide both sides by sine of 18 degrees. And the rest here is calculator work. So we are in degree mode. So now we're just going to press 8 divided by sine of 18 like this. And we press enter, and here's our solution. So once everything simplifies, now we have x equals, and to the nearest tenth, we look at the tenths place is an 8, and we look one to the right is another 8, so we're going to round up to 25.9, and our solution is choice 4. Now, one little extra detail here. Let's say you had a rare phobia of the sine function. What you could also do, let's say you wanted to do this, you could find that this missing angle over here is 72 degrees, because in every triangle in 2D, we have 180 degrees of total interior angle measure. And if you found this angle over here at 72 degrees, we could also say that this side here, that's 8 units long, is adjacent to the 72 degree angle. So we could say now that this is adjacent. This is still the hypotenuse because it's opposite of the right angle. And now we could say instead of using sine, we could use cosine, but we would have to use the 72 degree angle up here. So we could say cosine of 72 degrees. And remember, cosine is the ratio of the adjacent side, which is 8, over the hypotenuse is x. And then if we solve this one, we could just do the algebra here. This would give us, we would have x cosine of 72 degrees is equal to 8. And if we divide both sides by cosine of 72, this is going to give us a matching solution. Question 17, the measure of one of the base angles of an isosceles triangle is 42 degrees. The measure of an exterior angle at the vertex of the triangle is. For this one, I would draw this out first. So we have an isosceles triangle. So here's our isosceles triangle. We're told the base angles are 42 degrees. Well, technically they gave us one base angle, but in an isosceles triangle, the base angles are congruent. So both angles are 42, and the vertex is the angle that's not congruent with the others. So now we're going to draw in an exterior angle because that's our goal. We want to find what is the measure of the exterior angle at the vertex. So this is our vertex. So to find this, we could use the exterior angles theorem. This angle over here, so I'm going to just highlight this. This angle over here is equal to the sum of the two remote interior angles, the ones that are far away. So if I just do 42 plus 42, so I'm just going to add those two together, we get 84, and that's going to be the measure of this angle over here. Now, if I want to do this a different way, let's say I forgot the exterior angles theorem, then I could just call this x for now, and I could say x plus 42 equals 180, because we have three angles inside of a triangle, and they always add up to 180 when we're in two dimensions. So we have x plus 84 equals 180, and then subtract 84 on both sides, and that tells you the value of x. The value of x is equal to, that's going to give us 96. So once I know that this is a 96 degree angle, I could then do 180 minus 96 because this forms a straight line. And if we do the subtraction here, so let's go ahead and do that. So we'll borrow, and we have 4, and then 17 minus 9 is in fact 8. So 84, choice 2. So question 18, we have a whole lot going on. We have parallel segments here, and then we're told here that FH, so FH is congruent to LH. So we have this is congruent to this. And then next we're told that FL is congruent to KL. So that means these two segments here are the same. So far we have two isosceles triangles. And we're told LF bisects HFK. So it bisects angle HFK. So that means that this angle here is congruent to this angle here. And we want to know which statement is always true. Well, I said before that these two triangles are isosceles triangles. And the base angles of an isosceles triangle are congruent. So if these two sides are the same, the angles across from them are the same. So I could put a single notch here because we have a single notch here. And now in this second isosceles triangle, notice that across from the double notch, we have one of these angles marked off. So I can mark off angle FKL as being congruent to angle KFL over here. So now we have 4 congruent angles. And what I would do to make this question easier is put numbers here. put actual numbers. Put something, let's say here, like I put something like 25 degrees. So I'm going to put 25 degrees here. And that would mean that this is 25 degrees, and this is not necessarily drawn to scale. But then this would be 25 degrees over here because all 4 of those angles were marked off as congruent like this. Okay, so this is what we have here. And that would tell us right away that these 2 triangles are similar. But let's see if we actually need that. So once again, we're trying to find which statement is always true. So first up, 2 times the measure of angle HLF is equal to the measure of angle CHE. Well, if these 2 angles right now make 50 degrees, if I do 180 minus 50, the leftovers is 130. So why don't I write that in this place here? I have 130, and then this would be 130 because these are vertical angles like this. So let's think about that. 2 times the measure of angle HLF, that would be 50 degrees. If I double this, I get 50 degrees. Is that equal to 130? No, it's not equal to 130, so this is out. And now next we have 2 times the measure of angle FLK. So the measure of FLK, notice it's the missing angle, so this would also be 130. So if I multiply that by 2, I would get 260. And is 260 equal to LKB? Angle LKB would be 180 minus 25. So if I subtract here, so I'm just going to go ahead and do the subtraction, we're going to get, let's see, we get 155. So this angle over here would be 155 degrees. And think about that. Is 260 equal to 155? No, it is not. So this gets crossed off. Is the measure of angle AFD. So AFD would be vertical to this entire angle here. So notice the sum of these 2 angles. If I added those together, I would get 50. So this would be 50 over here. So is 50 degrees equal to BKL? BKL, the measure of this angle, is 155. So this one is also out. So now to the last one. Let's hope this is it. The measure of angle DFK. So the measure of angle DFK would be 130 because I could just do 180 minus 50. And that would tell me, because I have a straight line here, 180 minus 50 would give me 130, this missing angle. So I have 130. Is that equal to the measure of angle KLF? And yes, this is also equal to 130. So it took us a lot to get there, but choice 4 is definitely our answer. Question 19, we have a line whose equation is given here, and we're going to dilate this line by a scale factor of 2. And the center we're using is 0, 0. So we're using the origin. And we want the equation of the image. So for this one here, we need to identify the slope and y-intercept to be able to do this. So we're going to start off with this, and we're going to subtract 6x on both sides, because our goal is to get y by itself. So now 6x minus 6x cancels. We have 3y equals minus 6x plus 3. And now we're going to divide everything by 3 to get y by itself. So we divide everything by 3, and we're going to have y equals negative 6 divided by 3 is negative 2. So we have negative 2x plus 3 divided by 3 is 1. So now just think of this equation here. We have y equals mx plus b. So your slope is the coefficient of x. So our slope is negative 2, and our y-intercept, our b value here, is 1. So that tells us, if we draw this out, that our line is going to have a y-intercept over here at 0, 1. So if we're using a dilation with a scale factor of 2 and our center is at the origin, a nice little trick here is that I only dilate the y-intercept. So I'm going to take 0, 1, and I'm going to dilate this at the center 0, 0 by a scale factor of 2. So we're using the center 0, the center 0, 0, and we're scaling it by a scale factor of 2. So you're essentially just multiplying both of these by 2. 0 times 2 is 0, and 1 times 2 is 2. So our new y-intercept is going to be up here at 0, 2. So that tells us whatever our equation of our new line is, the new y-intercept, the new b value is 2. But one concept is that when you are dilating something like a line, so just imagine here I have this idea again. So I have this line, and I take any 2 points on the line. Let's say I scale this by a scale factor of 2, so I double the distance. That my new line is going to be parallel to my original line. So the slope does not change because parallel lines have the same slope. So my slope is going to stay negative 2. So my new equation, I'm ready. I have mx plus b is negative 2x. So I just write the slope in front of x. And I tack on the plus 2. Negative 2x plus 2, choice 2 is our answer. Question 20, which figure will not carry onto itself after a 120-degree rotation about its center? So let's start off with the equilateral triangle. So here's our equilateral triangle. If we spin this thing about its center, I imagine dotted lines coming out like this and touching each vertex of the triangle like this. Okay, so here's the dotted lines coming out. And you could imagine this circle concept. If we take 360 and we divide it by the number of points, that tells us the minimum angle of rotation that we need to carry this shape onto itself. So if I do 360 divided by 3, this tells us that we need to spin 120 degrees to carry this thing onto itself if we're spinning it from its center. Because you can see here that if each of these was 120, if we write each of these in, altogether that makes 360, okay? Because if we didn't spin by a multiple of 120, this thing would not land onto itself. So 1 is out because this one would work if we spin it 120. And now we think of a regular hexagon. Now we have 6 sides. So if we do 360 divided by 6, that means the minimum rotation we would need is 60 degrees. So if I did two 60-degree spins, so I find the multiples of 60, we have 60, 120, and then we would have 180. All of these spins would carry it onto itself. So that's why this one's out, because 120 would work. An octagon has 8 sides. So if we did 360 divided by 8, 8 goes into 36 4 times with the remainder of 4, and 8 goes into 45 times. So if I was counting by 45s, this one here would not work. Because if I count by 45, let's see, I have 45, so I'll do this right after. We have 45, then we have 90, and then after this we would have 135, we would have 180. See how we missed 120 degrees. So this would in fact be the answer. Now just to verify that 4 would work, we're going to take the nonagon, which has 9 sides. We do 360 divided by 9, and that would give you 40. So if you start counting by 40s, you have 40, you have 80, and then you have 120. So you see you would get 120 after you do 3 40-degree spins. So that's why 4 is out. Definitely choice 3. Question 21, we have triangle ADF, and we're told that segment BC and DF are parallel. So just know, anytime you have parallel segments going through a triangle, it's going to generate similar triangles. So I'm looking at this and I'm saying if I drew it this way, so let's say I switch it, I rotate it this way. I have ACB up here. This triangle ACB is going to be similar to the big triangle if I have triangle here AFD like this. Okay, so this is just something that I'm noticing right away. And that's going to help us set up the proportion in a moment. So we have AB over BC. AB over BC is the left to the bottom. Is that always equal to, now we have BD to DF. So notice that BD is part of the way down like this. So BD to DF is no good because AB over BC is like the entire left side over the entire bottom side, but BD is only part of the left side over the entire bottom side. So that's why this one is not a must be true. So this one is out. And now BC is equal to half of DF. Is BC always going to be half of DF? That's not necessarily true. If this was drawn at the midpoint, if we were told that these segments were congruent, then yes, BC would be half of DF. But if this is not drawn halfway from each side to the other like this, then that's not necessarily going to be true here. Let's just cross this off. So that's why this one is not necessarily true. Like maybe BC is like way up here like this, and these are still parallel, but it's not necessarily drawn to scale. So 2 is out. And now we have AB. I'm going to write it in fraction form. We have AB over AD. So that's the left side over the left side. Is that always equal to, we have AC, which is the right side, over CF. And CF is, once again, C is part of the way down. C is located along segment AF like this. So now if we look at this, AB over AD. So the left side over the left side is equal to the right side over part of the right side. So once again, this is a problem. So just by default, it has to be this. But let's see why this one is correct. We have angle ACB. So that's this angle over here is congruent to angle AFD, which angle AFD is over here. So notice that these angles are in corresponding locations. Similar triangles, all the corresponding angles of similar triangles are congruent. So this one is in fact our answer choice. So now before we move on, remember this big idea from geometry. When you have parallel lines being cut by a transversal, the corresponding angles are congruent. So when I look at angle ACB and angle AFD, what I'm imagining here is that if I extended these parallel lines going through like this, I'll draw that a little bit neater. We extend it like this. You could kind of see how it matches the diagram here if I were to rotate this around. That when I have parallel lines cut by this transversal, these are corresponding angles and they're going to be congruent. So definitely choice 4. Question 22, we have triangle ABC. So the first thing I'm going to do here is just draw out a triangle and we're going to name it ABC. So there's our triangle, triangle ABC, and we're told that capital M is the midpoint of segment AB. So I'm going to draw M right in the middle of this line segment, and we're told N is the midpoint of AC. So I'll put N over here. And then we're told MN is x plus 13. So I'm going to draw a line here, and we have this is x plus 13 units long, and then BC is 5x minus 1. What is the length of MN? So for this question, we have to know that when you connect the midpoints of two sides of a triangle, the segment formed is going to be parallel to the third side. So these are parallel, and the mid-segment is half as long as the side that it's parallel to. So that allows us to say here, we could say that MN, so I'm going to draw that a little bit higher. I'll write that a little bit higher. So MN is equal to half of BC. So now I just plug in. MN was x plus 13, and this is going to be equal to half of BC is 5x minus 1. Now, I could start this by distributing the half, but then we're going to have fractions, which is not going to be nice. So what I would rather do here is multiply both sides by 2. So I'm going to multiply the left and the right side by 2, because then 2 times the half just cancels out nicely. And I would much rather be working with these numbers. So 2 times x is 2x, plus 2 times 13 is 26, equals, and now we have a 1 in front of the parentheses. So we could just drop the parentheses and say 5x minus 1. And now from here, I'm going to go and subtract 2x on both sides. So I do minus 2x on both sides. This cancels out. We got 26 equals, that's going to give us 3x minus 1. Now just do plus 1. And you've got 27 equals 3x. Divide both sides by 3, and that tells you that x is equal to 9. But be careful. They're not asking you what is the value of x. If you pick 2, this is a dangerous bear trap. What you want to do, you want to find the length of MN. MN was x plus 13. So MN would be x is 9 plus 13. So this is equal to 22. Choice 4 is our answer. Question 23, we have a diagram of isosceles trapezoid star, and the diagonals are AS and RT. They intersect at O, and we're told that segment ST is parallel to segment RA, and the non-parallel sides are SR and TA. So which pair of triangles are not always similar? So since this is an isosceles trapezoid, the legs here, the non-parallel sides are congruent. And what we could also say is that the base angles are the same. So I could say that angle SRA is congruent to angle TAR. And I could also say here that angle RST, so these angles up top are the same. So this is just a result of this being an isosceles trapezoid. It has nice symmetry to it. So we have angle RST is congruent to ATS. So now let's go forward with this question. Let's see, which pair of triangles are not always similar? So STO, that's this triangle here, is similar to ARO. This one I can see right away. These are in fact similar because they have a pair of vertical angles here and they're going to be congruent. And because we have parallel segments, the alternate interior angles formed here are congruent. So you see these two triangles have two pairs of congruent angles. So they're similar by angle-angle similarity. So one is out. And now let's erase a little bit here just so we could see the other answer choices. Okay, so let's get this stuff out of the way. And now moving on to 2. SOR, so this triangle and triangle TOA. Well, not only are these similar, these are congruent. For questions like this, if you have a nice isosceles trapezoid, it has a lot of symmetry to it. The same way if I drew out a square and I look at this, I could say, all right, these diagonals are the same length. You don't need to do a heavy proof to establish that in the multiple choice. So I'm looking at this and saying these are the exact same size, not just the same shape, but they're the same exact size. So this, we could even say these two triangles would always be congruent, which would mean that they're also always going to be similar. They're going to be the same shape. So 2 is out. And now we look at 3. SRA, so that's this triangle here. Let's highlight this. We have triangle SRA is this triangle here going across the diagonal. And then I'll do this part in pen. SRA and ATS. Now the problem with this one, so I could already see that this one is no good, is when we look at this, you could see how SRA, the longest side is using the bottom here, whereas this triangle, the longest side is the diagonal. So I'm looking at this one here and saying that these two are not always going to be similar, because what we have is, you see how the angle up top here involves this and this angle. It's a big angle, whereas the angle here is smaller. Okay, the biggest angle in the highlighted triangle does not use this entire space. Like notice this little space over here, like this angle is not included in the highlighted yellow triangle. So right away, the top angles are not the same measure. And if all of the angles are not the same, the two triangles are not similar. So I could already see that it's going to be this one. But now let's rule out, let's see why choice 4 does in fact work out. Why are those two triangles always similar? So we have SRT, so that's this triangle here, S. So let me draw that a little neater, and I'll do it in highlighter. So we have SRT. So why is this triangle and TAS always similar? All right, so these you could see that not only are these triangles here always similar, but they're also always congruent. Because you see they share side ST. The diagonals, that's another theorem too. We could say the diagonals are congruent when you have an isosceles trapezoid. Okay, so I could say that AS is congruent to RT. So this is just a result of having an isosceles trapezoid. So right now they have two pairs of sides congruent. And then the third side here, the legs that we already established in the beginning, we said that SR and TA are the same. So now all three pairs of sides are the same, so they're congruent by SSS. So they're definitely similar. Choice 3 is our answer. Question 24, the last multiple choice question. So we have the endpoints of segment AB are here. Which equation of a line represents the perpendicular bisector of segment AB? So for this one, there's a few things to do, but I just think about what is a perpendicular bisector. It is a line that cuts a line segment in half and forms a 90-degree angle. So a lot's happening here. For one, it's crossing through the segment at the midpoint. So part of what we need to do here is we have to find the midpoint of segment AB. And the way that we do this is we take the average of the x values. So I'm going to take x1, y1, and x2, y2, and I'm going to take the average of the x values. So I'm doing 0 plus -4, and I'm dividing by 2. And then I have the average of the y values. I have 4 plus 6, and I'm dividing by 2. So first I need the midpoint. So the midpoint here, if we simplify, -4 divided by 2 is -2, and then 10 divided by 2 is 5. So there's our midpoint. And once I have the midpoint, I also need to know what is the slope of my perpendicular bisectors. So when I have AB here, this is not drawn to scale. I'm going to find the slope of AB, but then I need the slope of my perpendicular bisector, let's call it L, to be the negative reciprocal. That slope of L has to be the negative reciprocal of whatever the slope of AB is. So here, let's go ahead and find the slope. We have the difference of the y values. We have y2 minus y1 over x2, -4, minus x1 is 0. And now that's going to give us 2 over -4, which is -half. So I could say here the perpendicular slope is equal to, I flip and negate this. So this is going to flip to 2 over 1, and then I change it to a positive. So this is going to be 2. So now this is a nice equation to know. Y minus y1 equals m times x minus x1. Except I'm writing the equation of a line. Line L is passing through the midpoint. So I have to call this is my new x1, y1. So I'll just go ahead and erase this here. We'll get this stuff out of the way. This is my new x1, y1. So now I plug into this formula. I have y minus my y coordinate is 5 equals my perpendicular slope is 2. And then I have x minus x1. So if I do minus 2, that changes to plus 2. And now just do the algebra here. Let's see. So we've got 2x plus 4 after we distribute. We got y minus 5. So just add 5 to both sides. And now our final answer, we have y equals 2x plus 9. So we just scan the answer choices here. Let's see. Our solution is going to be choice 4.